Good morning. कितना लेट अपलोड किया? मैं कब से लेक्चर का लिंक बनाए बैठा हूँ. So tell me, what was the last topic we stopped at? Good morning, guys. Good morning. I'm not having a very good throat today, so I won't be able to shout. But I which ways don't shout. Okay. Everybody on the same page. I mean, like group 2 and its properties. What properties we discussed, Mira? Can anybody tell me quickly? Good morning, good morning. Hello. Good morning, everyone. What were the properties we were discussing? Because I'm a bit confused. General outer electronic configuration is NS2. Okay. Okay. We did talk about its atomic size and its ionization potentials. I do not remember. It's been a week or something. Yes, they will lose 2 electrons. Correct. Are we supposed to start with the reactions? If I'm not wrong. Have we discussed their physical properties, Katrin, about the atomic size, the ionic size, their metallic property, their oxidation number, and so on? Okay. मेरा गला थोड़ा खराब है तो इसलिए मेरा आवाज़ थोड़ा भारी है. That is the reason why I couldn't take lecture on Saturday, because my throat was absolutely bad. I couldn't speak. मैंने फिर भी पीटर इनका गागल वगैरह करके मैं अभी आया हूँ. Sir, IG, we will have to start with IP. IG. IP, ionization potential we talking about? Okay. Everybody in this batch is on the same page, if I'm not wrong. I mean, like, we are on the same part. ऐसा तो नहीं है ना कोई दूसरी batch से है वहाँ पे. अच्छा, IG is I guess. ये भाई दोबारा shortcuts. ओके. ग्रुप 1 का हो चुका था ना. ग्रुप 1 का आयनाइजेशन पोटेंशियल हो चुका था. सो व्हेन वी आर डिस्कसिंग इट इन ग्रुप, वी आर डिस्कसिंग डाउन द ग्रुप. व्हेन वी आर टॉकिंग अबाउट ग्रुप्स, वी आर टॉकिंग अबाउट डाउन द ग्रुप. इस तरीके से वी आर गोइंग डाउन. लिथियम, This is what we're talking about in group 2, right? So their general outer electronic configuration. अभी सपोज ये भाई साहब है अपना सेकेंड पीरियड में, ये थर्ड में है, तो S2 ऐसे से करके यहाँ पे it's going to be 7S2. So in the last shell, and the last shell and the last subshell is S for all of them. Obviously we're talking about buffering. Yeah, it was buffering, now it is fine, I guess. So we're talking about the last shell, two electrons. It is not a very big deal to remove these 2 electrons from the last shell. And we have already seen as we move down the group, we had seen atomic size of the elements, it increases. Now since atomic size is increasing, the distance between the nucleus and the outermost shell is increasing. It is becoming easier and easier for me to remove the 2. It becomes easier for me to remove the electron. If it is becoming easier for me to remove the electrons, I can pull out the electrons with less energy. What is this energy? This energy is ionization potential, ionization enthalpy, or ionization energy. What do I mean by this? These 3 terms. All of them are the same. It is the amount of energy required to remove the most loosely bonded electron in the outermost shell of an atom. So here there are going to be 2 ionization enthalpies. Why? Because there are 2 electrons in the outermost shell. The ionization enthalpy is going to be a little more as compared to group 1. Why? Group 1 elements are placed before them, right? अगर मैं before them की बात करूं तो across period the group, the ionization potential down the group, the ionization potential decreases. Why? Because the size is increasing. Since the size is increasing, it is becoming easier for me to remove the 2 electrons. As simple as that. It's buffering. अरे यार मैं इतना मेहनत से बोला और बफरिंग हो गया सब. Okay, I'll repeat. Is it okay now? अभी बफर नहीं हो रहा ना. I'll confirm कि बफर नहीं हो रहा है तभी बोलना स्टार्ट करूंगा, क्योंकि I don't want to waste my energy. Okay, fine, ठीक है. So what we were saying was the electrons in group 2. In group 2, the valence electrons or the last electrons, they are lying in the S subshell, and down the group as we are moving, the number of shells is changing. यहाँ पे 2, यहाँ पे 3, 4, 5, 6, 7 उस तरीके से, ठीक है. Down the group when I am moving, the size of the atom is increasing. Since the size of the atom is increasing, the distance between the nucleus and the outermost shell is increasing. The distance between the nucleus and the outermost shell is increasing this way. This distance is increasing. Right? So since this distance is increasing, it is the nucleus which is responsible to hold the electrons of the outermost shell. Since the distance is increasing, the hold of the nucleus on the outermost shell electrons becomes weak. If this hold becomes weak, it is easier for me to remove those electrons. When it becomes easier for me to remove those two electrons, I will require less energy. What energy I'm talking about? I'm talking about ionization energy, ionization potential, or ionization enthalpy. That is the energy required to remove the electron. Now when you are moving down the group in group 2, the size is increasing. Since the size is increasing, the amount of energy required to remove the electrons is going to decrease down the group. But when I compare them with group 1 का ionization potential, they have slightly more ionization potential as compared to group 1. Why? Group 1 का general electronic configuration is NS1, NS2 and so on. सेम रहेगा. यहाँ पे 1s2 आएगा, यहाँ पे 2s2 आएगा, यहाँ पे 7s1 आएगा. तो उनका नंबर ऑफ शेल्स तो सेम है, बट यहाँ पे एक ही इलेक्ट्रॉन निकालना है और यहाँ पे 2 इलेक्ट्रॉन निकालना है. तो ऑब्वियसली 2 इलेक्ट्रॉन निकालेंगे तो 2 आयनाइजेशन एंथैल्पीज का एडिशन जब मैं करूंगा तो ज्यादा हो जाएगा. सो एज कंपेयर टू ग्रुप 1, more in group 2 elements. Group 2 elements में ज्यादा एनर्जी लगेगा as compared to group 1 elements. That is what we are discussing. But as a whole, when I look at group 2, the ionization enthalpy keeps on increasing when we move down the group. Is this point clear about ionization enthalpy of group 2 elements? Very simple, beta. भाई वापस बफरिंग हो रहा है, ऐसे कैसे बफरिंग हो रहा है इतना? Definition of IP, it is the amount of energy required to remove the most loosely bonded electron in the outermost shell of an isolated gaseous atom. Amount of energy required to remove the most loosely bonded electron in the outermost shell of Supriya. होना तो नहीं चाहिए. Yeah, I could see थोड़ा सा बफर हुआ था. बीच बीच पे थोड़ा बफर हो रहा है शायद, but that's okay. Now Let us talk about the chemical properties of group 1 and group 2 together. ठीक है, ये रेडियम क्या बोलते ये होता है, रेडियो एक्टिव होता है। वहाँ पे जो लास्ट वाला एलिमेंट था अपने को आई सेड फ्रांसियम, वो रेडियो एक्टिव होता है। ग्रुप 1 का तो हमने डिस्कस कर लिया था, आईपी वगैरह, एटॉमिक साइज एंड मेटालिक कैरेक्टर, फ्री इलेक्ट्रॉन्स, गुड एट कंडक्टिविटी, मेटल्स, ये वो उनका अवेलेबिलिटी, नेचर, ये सब हमने डिस्कस किया था, इफ आई एम नॉट रॉन्ग, राइट बेटा? Now we are supposed to move on to its chemical properties, if I am not wrong. Okay, I'll repeat the definition, Khushbu. It is the amount of energy required to remove the most loosely bonded electron in the outermost shell of an isolated gaseous atom. The amount of energy required to remove a loosely bonded electron. Thank you, Sharayu. Yeah, I am actually well, I'm absolutely fine. I don't know, my throat has gone for a toss. COVID. But ठीक है, हो जाएगा ठीक। Okay. Now, when I talk about chemical properties of group 1 and group 2, अभी तक हम लोग फिजिकल प्रॉपर्टीज का बात कर रहे थे। अभी तक हम लोग फिजिकल प्रॉपर्टीज का बात किया। Now when I talk about chemical properties will be involving of chemical reactions. हम chemical reaction involves कर रहे हैं। When I say chemical reaction, it means it is combining with other elements. It is combining with other elements means it is forming a different compound altogether. The elements are losing their original properties and they are forming different elements different compounds altogether. So let us see how do group 1 and group 2 elements behave when we talk about their chemical nature, their bonding nature. Now, I told you just by looking at the electronic configuration, we can guess that ये जो एलिमेंट होगा वो केमिकली कैसे बिहेव करेगा, कैसे बॉन्ड्स बनाएगा, क्या होगा, एंड सो ऑन. ओके, so when I talk about group 1 and group 2, it's very simple that they have 1 and 2 electrons in their outermost shell. So obviously it is going to be easier for the elements to lose those electrons and form क्या बोलते हैं positive ions and come together in unison with ionic bond. So when you look at them, mostly all the elements are going to form ionic bonds. There is going to be exception with lithium and beryllium. Lithium from group 1 and beryllium from group 2. ये पहले दो एलिमेंट्स जो है मेरे ग्रुप 1 एंड ग्रुप 2 के साथ में पढ़ते हैं, ग्रुप 1 एंड ग्रुप 2 के. These group 1 and group 2 के first two elements are going to behave a little weird, are going to behave a little different. अगर सब लोग बोलेंगे इधर जाना है तो ये दोनों एलिमेंट्स बोलेंगे उधर जाना है. तो ये जो डिफरेंस है ग्रुप के मतलब ग्रुप के साथ ना चल करके अलग तरीके से बिहेव करना will be termed as anomalous behavior, will be termed as anomalous behavior. Now, what do I mean by anomalous behavior? I just told you it's not going to show you a normal trend. It is going to show you a little different properties. Now, why do lithium and beryllium are going to show anomalous behavior? Let us study together group 1 and group 2. ठीक है, अब ये anomalous behavior क्यों दिखाते हैं? The very first reason for their anomalous behavior is their small size, ये बहुत छोटू होते हैं. बहुत छोटू होने के कारण ना, both of them have only two shells, right? Lithium and beryllium दोनों के पास दो ही शेल है. लिथियम का इलेक्ट्रॉनिक कॉन्फ़िगरेशन is say 1s1 1s2 2s1 and beryllium configuration is 1s2 2s2 if I'm not wrong. Yeah, I'm right. So इन दोनों का कॉन्फ़िगरेशन ऐसा होता है. Now, is it visible or should I write a little bada? Yes, Steve, you are right. It is exceptional. The very first two elements are going to show exceptional behavior. That exceptional behavior is termed as anomalous behavior, different from the group. If I look at their electronic configuration, their sizes are very small. दो ही शेल्स हैं, तो न्यूक्लियस को उनको पकड़ के रखने में ज्यादा दिक्कत नहीं होती है. इट्स वेरी इजी टू हैव दिस न्यूक्लियस टू हैव अ होल्ड ऑन देम. सो दे हैव अ स्मॉल साइज. बिकॉज दे हैव स्मॉल साइज, दे हैव हाई आयनाइजेशन पोटेंशियल. They have a high ionization potential. आयनाइजेशन पोटेंशियल को ही मैं आयनाइजेशन एंथैल्पी या आयनाइजेशन एनर्जी बोल सकता हूं. दोनों का मतलब होता है सेम. आयनाइजेशन पोटेंशियल, आयनाइजेशन एंथैल्पी और आयनाइजेशन एनर्जी, three of them have the same meaning. So because their size is small, because the nuclear charge is more dominant, nuclear charge being more dominant and their size being small, the amount of energy required to remove the last electron, is more. Now nature क्या बोलता है कि जिसमें ज्यादा मेहनत लगती है ना, उसको ज्यादा छेड़ने का नहीं. तो अभी as compared to the reactivity of other elements in the group, ये दो elements are going to be a little away from quick reactions because IP ज्यादा है. इनका इलेक्ट्रॉन खींच के बाहर निकलने में ज्यादा टाइम लगता है. फॉरगेट अबाउट टाइम, ज्यादा एनर्जी लगता है. अभी अगर मैं आपको बोलूं कि आपको 2 बुक्स उठाना है और उसके बाजू में एक 12 बुक्स का सेट है, ऑल वेरी हैवी, obviously you will try to pick up the 2 books and run away because you will require less energy for that instead of picking those 12 books. So wherever energy requirement is more, we try to avoid that task, right? Same is with nature. Now since इसका IP ज्यादा है, इनका आयनाइजेशन पोटेंशियल ज्यादा. एक तो ग्रुप के सबसे पहले एलिमेंट्स ये है. डाउन द ग्रुप the ionization potential increases. Down the group, the ionization potential increases. Now, since ionization potential is increasing, down the group, the ionization potential decreases. तो अगर डिक्रीज हो रहा है तो सबसे ज्यादा किसका होगा? ऑब्वियसली सबसे स्टार्टिंग वाले एलिमेंट्स का. जो एलिमेंट्स स्टार्ट हो रहे, जिससे ग्रुप स्टार्ट हो रहा है, उसका सबसे ज्यादा आयनाइजेशन पोटेंशियल होगा. अब इसका आयनाइजेशन पोटेंशियल ज्यादा है तो इलेक्ट्रॉन निकलना आसान नहीं है, तो क्या आसान होगा? इलेक्ट्रॉन शेयर करना. तो जनरली दे फॉर्म कोवैलेंट बॉन्ड्स और if they are forming ionic bonds, the covalent character is going to be more. The covalent character is going to be more. Now what do I mean by covalent character? व्हाट डू आई मीन बाय कोवैलेंट कैरेक्टर? मतलब आयनिक बॉन्ड तो बनाया लिथियम ने, ये लिथियम है, ये दूसरा आयन है, ये नेगेटिव आयन है, लिथियम पॉजिटिव आयन है, ये नेगेटिव आयन है। अभी लिथियम का साइज छोटा होता है, इतना छोटा होता है, थोड़ा प्रपोर्शन वाइज बनाता हूं बेटा मैं। सपोज दिस इज लिथियम एंड दिस इज द नेगेटिव आयन विच इज कमिंग नाउ एज कंपेयर टू दिस नेगेटिव आयन। ये लिथियम या बेरिलियम का आयन को देखो, इसका जो इलेक्ट्रॉन्स है बहुत ज्यादा इलेक्ट्रॉन्स है ना, और यहाँ पे इतना सा है बस, है ना। तो इसके इतने सारे इलेक्ट्रॉन्स इसके न्यूक्लियस को अपनी तरफ खींचने की कोशिश करेंगे। क्यों? बिकॉज दे आर डोमिनेंट एंड दिस इज स्मॉल। तो खींचने के चक्कर में क्या होता है, आयनिक बॉन्ड के अंदर ही थोड़ा सा ओवरलैपिंग हो जाता है, थोड़ा सा ओवरलैपिंग हो जाता है। This is called as covalent character in ionic bond. This is called as covalent character in ionic bond. उसके छोटे साइज के कारण जो बड़ा नेगेटिव आयन है, आयनिक बॉन्ड बनाते वक्त उसको थोड़ा अपनी तरफ खींच लेता है, बिकॉज इट हैज मोर पावर एंड इट पुल्स इट्स न्यूक्लियस टुवर्ड्स इटसेल्फ, जिसकी वजह से आयनिक बॉन्ड के अंदर ही ओवरलैपिंग हो गया। सो आयनिक बॉन्ड के अंदर कोवैलेंट कैरेक्टर आ गया, तो ये बॉन्ड और ज्यादा स्ट्रांग हो गया, इसको तोड़ना और डिफिकल्ट हो गया। सो दैट इज इट जनरली विल टेंड टुवर्ड्स फॉर्मिंग कोवैलेंट बॉन्ड्स। इफ इट इज फॉर्मिंग आयनिक बॉन्ड, the covalent character is going to be more in those ionic bonds. Covalent character is going to be more in those ionic bonds. Yeah, it decreases. I just told you बेटा मयंक, मैंने अभी just बताया what is covalent character. It is the presence of overlapping in ionic bond. Ionic bond में जब नेगेटिव आयन बहुत बड़ा होता है और पॉजिटिव आयन छोटा होता है, the negative ion, the electrons of the negative ion, they tend to attract the nucleus of the smaller atom. In doing so, they pull the ion towards cation towards itself, and a small overlapping takes place. This is called as covalent character in ionic bond. This is called as covalent character in ionic bond. तो ये लिथियम और बेरिलियम दोनों का, if they ask you why do lithium and beryllium show exceptional behavior or different behavior as compared to other elements in the group, the answer is going to be because of their small size and their high ionization potential. They have a tendency to form covalent bonds and show covalent character, which is different from all other elements because उनका size बड़ा होता है and उनका IP कम होता है. That way, this is the main reason why they are not behaving like the other elements in the group. Simple. Is this point clear? Now, if ये थोड़ा सा लिख लो जो भी बोर्ड पे लिखा है बेटा. If I switch off the light, is it okay? Is this visible enough? Natural light is good. बोर्ड दिख रहा है बेटा? Sir, means covalent character is found between a small sized ion and large sized ion. Yes, Sharayu, covalent character is found between a small sized cation and a large sized anion. That would be more precise to say small cation and large anion. ये लिख लिया बेटा बोर्ड पे जो मैंने लिखा हुआ है? Can I erase this from the board? Sharayu, generally the small ion is always the cation, because cation will lose electron. Cation loses electron, and that is the reason why it shrinks. And anion gains electrons, and that is why repulsion happens and its size increases. Hey, Alan, I'm glad to see you are alive and you're back. What happened, beta? Alan, I didn't understand. You're saying yes, happened. Okay. Can I rub this from the board? Can you retype the question, Alan? I didn't get your question, beta. It did not deliver. Can you please retype and resend that question? When we talk about chemical properties, the very first property that we'll be looking at is the reaction with air. Now, when I talk about reaction with air, the most reactive gas in air would be oxygen, of course. So these elements, ये जो elements हैं हमारे, these elements are very reactive, group 1 or group 2 if I talk about. So group 1, I'm talking about lithium, I'm talking about potassium, I'm talking about calcium. First three elements will be more important, of course, but the other elements will follow the lead. And these elements from group 1 and group 2, they will readily get oxidized, and when exposed to air they form a layer of oxide on them, very similar to iron. When iron is exposed to air and moisture, it forms iron oxide, but it takes a very long time for iron oxide to form. ऐसा नहीं है कि आपने आयरन अगर ऐसे रख दिया हवा में तो तुरंत वो लाल हो जाएगा या फिर तुरंत आयरन ऑक्साइड बन जाएगा. Here it's going to be very quick because of their highly reactive nature. Why are they highly reactive? Of course they'll be highly reactive because they will very easily lose that 1 and 2 electron. They want to attain stability quickly because they can. Why can they? Because they have only 1 electron or 2 electrons to lose. They do not have to get involved in many bond formations कि इनको 3, 4, 5 bonds बनाने हैं, ऐसा कुछ करना है नहीं. They just have to simply get rid of the last shell electron and form a bond. So the easiest of the reaction that they will undergo is oxide formation. All of these elements will readily react with air to form oxides, to form their corresponding oxides. Now ग्रुप 1 के जो एलिमेंट्स है they will form with oxygen. When reacted with oxygen, they form normal oxides, they form peroxides, and they also form superoxides. So क्या बोलते हैं, not this, sorry, this way, normal oxides, lithium oxide, okay, they will form peroxides and they form superoxides also. Now if you find the oxidation state over here, oxygen का oxidation state is going to be -2, oxygen का यहाँ पे oxidation state is going to be -1 and यहाँ पे it's going to be -half. So oxide, peroxide and superoxide, all types of oxides you can see in the group 1 element. Now depending on the size, depending on the ionization potential, the compatibility of the negative oxide ion and the positive group 1 element, they are forming different types of oxides. But at the day's end, you can generalize that they readily react with oxygen to give you corresponding oxides. This statement is more than enough. They react with oxygen to give you oxides. Oxygen का layer बनाते हैं and they form oxides. Now the problem is lithium and sodium and potassium. Sodium and potassium are very reactive, highly reactive. So when exposed to air, definitely they will form oxides, but they will easily catch fire also because the reaction is highly exothermic. This reaction is highly exothermic. What do I mean by exothermic? Exothermic reactions are those reactions in which heat is given out when the reaction is occurring. Now the speed at which heat is being given out when sodium and oxygen and potassium and oxygen are combining is very high. The speed is so high that when heat is coming out, it catches fire, the compound catches fire, and these sodium and potassium, they actually burn. They actually burn in the presence of oxygen. ये इतने reactive होते हैं बेटा, and that is the reason why you cannot keep them in open air. Because हमने अगर सोडियम और पोटेशियम जैसे एलिमेंट्स को ओपन एयर में रखा in the natural state, of course, मतलब only sodium या only potassium को, if I keep it openly in the air, it will easily catch fire, and that is the reason why I need to store them under a liquid. Now under a liquid also I have to store them under kerosene and not water, because in the reactions ahead we will see they easily react with water also. Yes, those reactions are highly exothermic beta. Superoxide. A superoxide is a compound in which the oxidation state of oxygen is considered to be -half. Now, why do I say this? पहले मैंने बोला था ग्रुप 1 के जितने भी एलिमेंट्स होंगे, ग्रुप 1 का जनरल कॉन्फ़िगरेशन इज NS1. Group 1 का general configuration is NS1. These elements, they will lose an electron and they will form positive ion. E is for element. E is for element. They will lose an electron. Elements of group 1, they lose an electron and they form positive ion. अब लिथियम ऑक्साइड को कंसिडर करो, इसका ऑक्सीडेशन स्टेट +1 है, ऑक्सीजन का नहीं पता, X ले लो. It is a neutral compound because there is no charge on it. So how will I write 1 + X is equal to 0. The addition of the oxides, the oxidation number is always supposed to be 0 in a neutral compound, in a neutral molecule. Okay. So here when I consider x will be -1. So yeah, sorry, it's not going to be +1, it's going to be -1, and this is also going to be a peroxide. So it's peroxide matlab when the element and oxygen is combining in the same ratio, 2:2, 1:1, 3:3, that way. Okay. Per oxide, same number of elements. Now consider Na2O2. Na2O2. Sodium being group 1 element, इसका ऑक्सीडेशन स्टेट x1 है, इसका x है. 2 into 1 is 2, plus 2x is equal to 0. So 2x is equal to -2. x is equal to -1. यहाँ पे भी ऑक्सीजन का ऑक्सीडेशन स्टेट -1 आ गया. ठीक है. सो पोटेशियम ऑक्साइड, ठीक है, पोटेशियम ऑक्साइड, potassium is +1, oxygen is x, so 1 plus 2x is equal to 0, 2x is equal to -1, x is equal to -1/2. यहाँ पे ऑक्सीजन का ऑक्सीडेशन स्टेट आता है -12. I am assuming that you know how to find out the oxidation state. ये आपको हो चुका है चैप्टर ऑक्सीडेशन स्टेट and oxidation number में. Is this clear, Supriya? ये -12 कैसे आया? Supriya, I know that sodium and potassium is +1 because I told you beginning में the outer configuration is NS1. So they will easily lose that one electron and form plus and have a +1 charge on it. The charge on the element after losing or gaining the electron is known as its oxidation state or oxidation number. तो group 1 है तो +1 ही रहेगा that way. नहीं बेटा, जो प्रीफिक्स है उसको कंसीडर नहीं करने का, जो सफिक्स लगा रहता है कंपाउंड में ये ढूंढने के लिए, ऑक्सीडेशन नंबर ढूंढने के लिए सिर्फ अपना सफिक्स रहता है. यस, इट डिपेंड्स ऑन द ग्रुप नंबर. ऑक्सीजन के मल्टीपल ऑक्सीडेशन स्टेज होते हैं, यस, but generally it is -2. General oxidation state of oxygen is -2 because it requires 2 electrons to complete its octet. But there are going to be different exceptions. Oxygen with fluorine, only with fluorine, has oxidation state of +2 because fluorine is more electronegative than क्या बोलते हैं, oxygen. So what is this oxidation number concept? Oxidation number concept क्या होता है ना, it depends on the two elements which have combined together. उनका इलेक्ट्रोनेगेटिविटी हम लोग कंपेयर करते हैं. जो ज्यादा इलेक्ट्रोनेगेटिव होगा उसको नेगेटिव ऑक्सीडेशन नंबर देंगे, जो कम इलेक्ट्रोनेगेटिव होगा उसको हम अज्यूम करेंगे कि ये भाई इलेक्ट्रो पॉजिटिव होगा. So as compared to fluorine, इस कंपाउंड में OF2 फ्लोराइड इसमें ऑक्साइड में fluorine is more electronegative than oxygen. तो को हम -2 ऑक्सीजन +2 हो जाता है, -1 लेते हैं, सॉरी, fluorine is -1 and oxygen +2 हो जाता है. Only with fluorine oxygen is +2, otherwise everywhere else you will find oxygen will always have a negative oxidation number. There is a chapter called as redox reaction, उसके अंदर आपको डिटेल में सिखाया जाएगा ये. But how to find oxidation number, it's a different chapter altogether. Redox reactions, very interesting chapter, बहुत मजा आएगा आपको सॉल्व करते पढ़ते वक्त. Now when I talk about this superoxide, why am I calling this as superoxide? This superoxide has the capability of absorbing carbon dioxide. It absorbs carbon dioxide and forms potassium carbonate. At the same time, it releases oxygen. Forget about the balancing part, pay attention on what reaction I'm talking about. This superoxide, why am I calling it as a superoxide is, it has the capability, it has the potential to absorb carbon dioxide, to combine with carbon dioxide and form carbonate compounds. At the same time, it can release free oxygen. This property is used in oxygen cylinders when we are climbing the mountains. When we are climbing the mountains, we are continuously releasing carbon dioxide. When we are breathing out, that carbon dioxide अपने मुंह पे ऐसा मास्क लगा रहता है. वो कार्बन डाइऑक्साइड पाइप से सिलेंडर में जाता है जिसके अंदर पोटेशियम ऑक्साइड है. It combines with potassium oxide to give potassium carbonate, and fresh oxygen is released, which is used for breathing. This oxygen is used for breathing because at heights you do not have oxygen free, or rather the percentage of free oxygen at heights is less because the air is thinner, and that is why you need oxygen cylinders over there. So this is the principle which is used in oxygen cylinders at height. अभी बताओ ना. अरे बेटा, इट्स अ लॉन्ग प्रोसेस बेटा, वो दूसरा चैप्टर हो जाएगा ऑल टुगेदर. बिकॉज ऑक्सीडेशन स्टेट ढूंढने के लिए मेरे को पहले आपको रिडॉक्स बताना पड़ेगा, उसके बाद मुझे आपको रूल्स बताने पड़ेंगे. देयर आर सम 8 to 9 रूल्स ऑफ असाइनिंग ऑक्सीडेशन नंबर. देन वो तो इट्स अ डिफरेंट टेंजेंट ऑल टुगेदर. हम टॉपिक से बहुत ज्यादा डाइग्रेस कर जाएंगे. आपको जल्दी सिखा देंगे उस चैप्टर में, डोंट वरी अबाउट इट. इट्स अ सेपरेट टॉपिक ऑल टुगेदर बेटा. बेटा सुप्रिया, OF2 ऑक्सीजन डाइफ्लोराइड. ओके, सो फ्लोरीन इज द मोस्ट इलेक्ट्रोनेगेटिव एलिमेंट. फ्लोरीन क्या करता है, एक इलेक्ट्रॉन एक्सेप्ट करके अपने ऊपर -1 चार्ज लेके आता है. अब यहाँ पे ऑक्सीजन का ऑक्सीडेशन, ऑक्सीजन का चार्ज क्या होगा मुझे नहीं पता. दोनों का चार्ज मिला के 0 होना चाहिए, बिकॉज OF2 के ऊपर कोई चार्ज नहीं है. इट इज अ न्यूट्रल कंपाउंड. सो -1 एक फ्लोरीन का, 2 का कितना होगा -2, -1 into 2 प्लस एक ऑक्सीजन into X, इट शुड बी 0. सो X क्या हो जाएगा +2. So oxygen is +2 only with fluorine, because fluorine is more electronegative as compared to oxygen. Otherwise, all other elements are less electronegative as compared to oxygen. So fluorine is the first most electropositive element. Then comes oxygen, and then the other halogens. हाँ करेक्ट. अगर मैंने ऑक्सीडेशन सिखा दिया ना, ऑक्सीडेशन नंबर कैसे निकालना है, तो आधा रिडॉक्स चैप्टर वही हो जाएगा. ठीक है. सो नाउ ये जो ऑक्साइड्स मेरे को मिले हैं ग्रुप 1 के, ये ग्रुप 1 के जो ऑक्साइड्स हैं, दे आर हाईली बेसिक इन नेचर. लिथियम ऑक्साइड बोलो then sodium peroxide बोलो, potassium oxide बोलो, they are highly basic in nature. Now, how do I know they are basic in nature? When I mix them with water. When I mix them with water. So, for example, lithium oxide को water के साथ mix किया, तो it forms lithium hydroxide. It gives me lithium hydroxide. It gives me lithium hydroxide. Balancing part आप लोग अभी नहीं देखेंगे, बाद में देखेंगे. So lithium oxide when reacted with water, it gives me lithium hydroxide. This lithium hydroxide is क्या बोलते हैं? It is basic. It is basic. This is a base. This is a base. Lithium oxide is a base which is highly soluble in water. It is highly soluble in water. Easily soluble in water. So bases which are soluble in water are called as alkalis. Alkali are called as alkali. Bases which are soluble in water are called as alkalis. Metals of group 1, they form oxides which are readily soluble in water and are basic in nature. So they are bases which are readily soluble in water. That means they are alkalis, and that is why these metals are called of group 1 we are talking about. That is why they are called as alkali metals. That is why group 1 metals are called as alkali metals. That is the one reason why group 1 metals are called as alkali metals. Just give me a second. Okay, so these metals, they form oxides which are basic. These oxides are readily soluble in water. Bases which are soluble in water are called as alkalis, and that is why group 1 elements are called as alkali metals. Is this clear, बच्चों? ये reason clear है? Why are they called as alkali metals? Have you written this down? Can I rub this? Have we written this down? Light तो नहीं आ रहा है बोर्ड पे. Should I cover it like this? Okay. ग्रुप टू के एलिमेंट्स की जब मैं बात करूं, ग्रुप टू के एलिमेंट्स मैग्नीशियम ले लेता हूं. मैग्नीशियम इट रिएक्ट्स विथ ऑक्सीजन टू गिव यू मैग्नीशियम ऑक्साइड. ओके, मैग्नीशियम ऑल्सो रिएक्ट्स विथ नाइट्रोजन to give you magnesium nitrate, Mg3N2, magnesium nitrate. It gives you like this. Am I right? Yes, I am right. Magnesium nitrate. इसको बैलेंस कर लो तो ऐसा हो जाएगा ये. So ग्रुप टू का जो एलिमेंट्स है, ग्रुप टू के जो मेरे एलिमेंट्स है, they will react with both oxygen and nitrogen and give you a mixture of oxides and nitrites. They give you mixture of oxides and nitrites just because they have one valency more as compared to group 1 elements. Group 1 का valency क्या है 1, group 2 का valency क्या है 2. तो उस हिसाब से अपने आप को एडजस्ट करके अलग कंपाउंड्स दे सकते हैं. So they give you group 2 का एलिमेंट जो होगा they will react with in air. They will also readily react with air because only you have to lose 2 electrons. Though they form a mixture of oxides and nitrites. ऑक्सीजन के साथ भी रिएक्ट करेंगे एंड नाइट्रोजन के साथ भी रिएक्ट करेंगे. सो ऑक्सीजन और नाइट्राइट का कॉम्बिनेशन अपने को, ऑक्साइड और नाइट्राइट का कॉम्बिनेशन अपने को मिलता है. सिंपल एज दैट इन ग्रुप 2. ओके, व्हेन आई टॉक अबाउट when I talk about their hydroxides, these group 2 का जो hydroxide होता है with water of course, when these oxides when they combine with water they will form corresponding hydroxides. In nature you get these hydroxides, the elements, they are not present in the free state. They are present as hydroxides in nature. In the earth's crust, the salt which is there, it is present as a hydroxide. Magnesium hydroxide, calcium hydroxide, उस तरीके से. तो ये हाइड्रोक्साइड के फॉर्म में नेचर में प्रेजेंट होता है. That hydroxide when dissolved in water is basic. Okay, and that is why they are called as alkaline earth metals. अर्थ वर्ड एक्स्ट्रा क्यों लग रहा है? बिकॉज ये नेचर में एज अ सॉल्ट इट इज प्रेजेंट रेडिली. इट इज अवेलेबल इन द अर्थ क्रस्ट इन दैट हाइड्रोक्साइड फॉर्म विच इज soluble in water on which is basic also in nature. So that is why these group 2 elements are called as alkaline earth metals. They are called as alkaline earth metals. Okay, so that is this part. I hope you are noting all this. I am not full of energy because I do not want to stress my throat. If I stress my throat, I'll have repercussions. That's why I am speaking softly today. I am continuously drinking warm water, hot water. Okay, Alan, I'll repeat. What I said was, ग्रुप 2 के जो हाइड्रोक्साइड्स होते हैं, ग्रुप 2 हाइड्रोक्साइड्स आर alkalis. Means when I react these oxides with water, they will form hydroxides. These oxides are readily soluble in water and they form क्या बोलते हैं alkali of OH टाइप, मतलब मैग्नीशियम हाइड्रोक्साइड एंड सो ऑन जितने एलिमेंट्स हैं. ये जो हाइड्रोक्साइड्स होते हैं ग्रुप 2 के, दे आर अवेलेबल इन द हाइड्रोक्साइड फॉर्म इन द अर्थ क्रस्ट. अर्थ के क्रस्ट में दे आर फाउंड दीज ऑक्साइड्स and these hydroxides are found in the earth's crust in the oxide and hydroxide form. So they are not found in the free state, they are found in the oxide state only, and they are alkaline in nature. मतलब when I put them in water, they dissolve to give you a basic solution. So bases which are soluble in water are alkalis. Now these compounds which are basic in nature are found in the Earth's crust. Group 2 की बात कर रहा हूँ मैं. These compounds which are basic in nature are found in Earth's crust. That is why we are calling them as alkaline earth metals. दोनों का मतलब सेम है. They are alkali metals, they are alkaline earth metals. Earth वर्ड इसलिए इंक्लूड किया है बिकॉज ये अर्थ के क्रस्ट में ऑक्साइड के फॉर्म में प्रेजेंट होता है. दैट वे इसके स्टार्टिंग के एलिमेंट्स ऑक्साइड के फॉर्म में एग्जिस्ट नहीं करते बिकॉज इतना एक्सोथर्मिक है कि आग लग जाता है. Great, cool. Now same happens with water. These elements, I'm not talking about their oxides, I'm talking about the elements. ठीक है, अभी तक मैं ऑक्साइड को पानी में मिला रहा था, which was क्या बोलते हैं, forming hydroxide. Now when I talk about the element, so for example group 1 का element ले लो lithium, group 1 का element ले लो, सोडियम की बात करते हैं पहले. When I talk about sodium and water, the reaction with water, what do you think is going to be formed over here when I simply put sodium in water? Sodium को simply पानी में डाल दो. Sodium will very easily lose a electron. ठीक है, and क्या बोलते हैं, sodium will very easily lose an electron. Water is going to break into H plus and OH minus. That H plus is going to accept the electron released by sodium and form hydrogen gas. It is going to release hydrogen gas. Here you can see water being acted like an acid. Water is amphoteric in nature. Water behaves both like acid as well as bases. Any metal when reacted with acid will release hydrogen gas, right? तो यहाँ पे sodium is the metal, water is amphoteric, it may act as an acid or as a base. Here we see the acidic nature of water. Water breaks into H plus and OH minus. Sodium being highly reactive will release an electron. This electron will be accepted by this H plus and it will form H2O. और बचेगा solution में क्या, Na plus and OH minus. Now this reaction जो है यहाँ पे, ये reaction, this reaction is highly exothermic. Again, it is highly exothermic. Now since it is highly exothermic, sodium when put in water, it burns. It burns. सोडियम को, अगर सिर्फ सोडियम मेटल को, सोडियम ऑक्साइड की बात नहीं कर रहा हूं मैं, अगर सिर्फ इफ ओनली सोडियम मेटल इज पुट ऑन वाटर, इट विल स्टार्ट बर्निंग. It will start burning because it readily releases this electron, and this process is highly exothermic, and that is the reason why they will burn. Sodium, potassium, they will burn when put with water. Lithium on the contrary reacts slowly with water, so lithium is not going to burn because of its anomalous behavior, because of its high ionization potential, because of its small size. Okay, so lithium is going to react very slowly, but potassium and sodium when put in water, they are going to readily burn and give you a highly exothermic reaction when directly mixed with water. This is the reason why sodium is not stored under water and stored under kerosene, जो आपने बचपन में देखा होगा, बचपन में सुना होगा. ठीक है, इज दिस क्लियर? सोडियम बर्न्स बिकॉज ऑफ द हाईली एक्सोथर्मिक नेचर. इतना आसानी से वो इलेक्ट्रॉन निकलता है ना कि इट इज लाइक, कैसे बताऊं, ये देखा आपने अपना एनिम का वो कार्टून आता है एंड ऑल, तो उसमें जब एकदम से पावर आता है तो वो ऐसा करता है तो एकदम से आग निकलती है, हीट निकलती है, एंड द पर्सन स्टार्ट्स बर्निंग इनटू फ्लेम एंड ऑल द कैरेक्टर. So that is, lithium does still release heat during reaction, right, sir? No, Alan, lithium will not release that much amount of heat. So lithium won't burn. It will react very slowly, but sodium will readily burn that way. Okay. It's because of the एकदम very quick tendency to lose electrons. Yes, DBZ, correct. On the other hand, when I talk about group 2 elements, beryllium does not react with water. Beryllium and water, no reaction. Beryllium itna by electronic configuration 1s to 2s2 all क्या बोलते हैं, जो भी ऑर्बिटल्स में इलेक्ट्रॉन्स है completely fill. Yeah, Dragon Ball Z is the right what I was saying. So 1s to 2s2, so this does not react with water at all. Magnesium, yes, it reacts with water, with warm water, and it forms the corresponding hydroxide. Magnesium hydroxide, Mg2OH3 है कि MgOH2, Mg, not magnesium, I'm sorry, calcium, I'm talking about magnesium तो यहाँ था. Calcium hydroxide, it forms CaOH twice. Calcium hydroxide बनता है with the release of hydrogen, of course. So what is happening over here? Calcium is losing its 2 electrons. These two, and water is breaking into H plus and OH minus. These 2 electrons are combining with H to give me H2. Calcium combines with OH to give me calcium hydroxide का precipitate. All other elements also behave like this, but with cold water. Calcium is the one which reacts with hot water. Is this clearly visible, or I am making too much of khichdi? Is it buffering a bit? I'm sorry. No, it's not buffering. ठीक है बच्चा, कैल्शियम ये लिखा तुम लोगों ने, ये इस तरह से लिखोगे ना प्रॉपरली. यहाँ पे थोड़ा बफरिंग हो रहा है शायद. आई एम सॉरी फॉर दैट. Calcium hydroxide का precipitate and H2 gas is released. This calcium, it loses 2 electrons. Water breaks into H plus and OH minus. These 2 electrons are going over here and it releases H2. Calcium combines with OH to give me calcium hydroxide. This is easier. This is a better way to understand. ये same reaction, this same reaction का हुआ रहेगा buffer. I'm sorry, please. उसको जरा सा एडजस्ट कर लो, थोड़ा सा देख लो. Is it clear now? So this is how the individual elements are reacting with water to release hydrogen. which is also proving that water is an acid over here. Simple reactions. Why is it buffering so much? Actually, guys, I have a 9 o'clock meeting now in office. So let us stop here. I don't want to stress my throat much. Let us meet again in the next lecture and we will continue. Water के साथ reaction हो गया है, oxygen के साथ reaction हो गया है. We will see how group 1 and group 2 elements react with hydrogen and other compounds, and we will see. Let us meet soon in the next. Have a great day ahead, guys. Take care of yourselves. Please take care of the rising cases.